Hello, hope you're having a great day. My name is Stephen Singer, and in this video lecture, we're going to discuss about object-oriented programming. Now, object-oriented programming is a very common way to structure your code so that it feels more intuitive and it's easier to collaborate with other developers. It's commonly implemented in many programming languages, one of them being Python. Now, in this video, we're going to discuss about three main topics. First, we're going to have a recap about what variables and functions are. Second, we're going to discuss or try to define what an object and class is, and then give some examples about them so you can build some intuition into seeing objects and classes. And then third, we're going to implement our own class and then create our own objects in Python. So we have a lot to discuss, so let's get started. First, what is a variable? Now, a variable really is just container for data. This data can take on many forms. It can be an integer, it can be a decimal or float, it can even be a boolean, which is true or false. It can even be a string or a text like hello world, your first name, or that kind of things. It can even be a list of those data that we've already mentioned. It can be a list of strings, list of integers, etc. Uh, so really, yeah, variables are just containers of data. But one way you can think about variables this way is that they're aliases. What do I mean by this? So I'll share my screen for a moment just to prove my point. Okay, so you can see my screen now, hopefully. We're in the Python console here in the terminal. And so let's define a variable. We're going to name it uh, H, and then let's give it 25, a value of 25. Now, if I give you the number 25 as is, you wouldn't make sense of it, right? It's just the number 25. In the computer, it's the same as well. But uh, when we try to use the variable name age, it does give it its context, and then it becomes its alias as well. So instead of saying 25, so say we want to know the age plus 3, instead of saying 25 plus 3, which is very confusing, we wouldn't know what 25 is in this context, we can say age plus 3. So it makes more sense. And age, if you just input it, is really just 25. It's an alias. And okay, so I'll stop sharing for now. Next, we're going to discuss about functions. Now, functions, you can also think about them as aliases as well, but this time for processes or codes, so they're just mini codes. What do I mean by this? Uh, well, I guess we're going to go through the share screen again. Okay, so examples. Hopefully you can see my screen now. I'll exit the console right now and then clear. Okay, so look at this function here. So define some square, which takes in numbers. This will probably be a list. And then what it does is it adds all of those numbers, except each number is squared. Okay, and then you can see the output here. Let's wrap it in the print function. And then let's run this code. So examples. It's 14 because 1 plus 4 plus 9 is 14. Okay, what's the point I'm trying to make here? I'm trying to make is instead of having to do this like lines of code every time we want to compute the sum squares, uh, we just write the function sum squares. So we've made an alias for that entire process. That entire instruction has just become one name. What's an example of this in real life? Say I tell you, can you please open the door? I'm not going to tell you to hold the doorknob, slightly turn it, and then pull or push it. That's so specific. That's so many processes that you don't really need to know because in your head, you already know the function open, right? That open does have some specific steps, but just say the word open. It makes more sense. So that's what functions are in this case. They're aliases of processes. I'll stop sharing. Uh, we'll go through code later on, but now we know what variables and functions are, we can move on. Sorry, we can move on to objects. What are objects then? Well, objects in the simplest sense is really just a collection of variables and functions. But that description kind of discredits what object oriented programming stands for. So let's give some more insight. You need to think about two keywords when we're dealing with objects. First is has, and second is do or does. Let's go through them one by one. Has. An object has certain variables. It has those variables because it gives it its identity. By by having those variables, we get to know more about that object and we get to define it more. What do I mean by this? I'll give you an example. Let's think about an employee. What makes an employee an employee? Well, uh, based on, say, a formal system, you would think, an employee would probably have an employee ID, right? They would also have a department where they work in. They would also have a company, of course, where they work in as well. So by having those properties, by having those variables, they are defined as an employee. So say you see some random person outside. You know that they have an employee ID. You know that they have a department they work in. You know that they work in this certain company. You could call them an employee. Why could you call them an employee? Because they have those variables. It exists in them. It has. They have those variables. Next, let's have the keyword do or does. One way that we can describe an object is by how it behaves or what it does. One good example I could think of is our cats. Uh, what makes a cat a cat? Well, one response I always say to that is a cat is something or an entity that meows because when something meows, it's more cat-like, right? So, by having a function. Let's call it a function. But having it a function or something, a process that it does, it becomes more defined. You associate it with that function. So a cat would probably have a function, and that function would be called meow, right? And then a function would probably also have variables like the color of their fur, their breed, those kinds of things. So by having those variables inside of them, you get to know more about these things and then you get to make more sense about it. And that's why object oriented programming is so intuitive because in the real world, you don't really see variables, right? You don't see X here, you don't see 25 uh like random data. What you see are objects, things that interact with each other. You see a cat rolling a ball, you see a person opening a door. So there's something that has properties, has variables that we should probably call it's actually called attributes. So this object has attributes. Attributes variable, same thing, and then they do certain tasks, they do certain functions, they have methods. So that's what we call functions that are inside objects. So that's why object oriented programming is more intuitive because you're thinking about how things interact with each other based on what they have and what they are capable of, which is usually what happens in real life rather than just very structured relationships that happens line by line. That doesn't usually happen in real world, right? That rarely happens. So that's what the intuition is with objects and with objects. But I haven't discussed about classes yet, right? Classes. So what's the difference between a class and an object? So I'm going to describe this using an analogy. Let's say we have a house, right? A house can have a blueprint. So classes really are just blueprints. So let's look at the blueprint. So a blueprint of a house will probably have the number of floors, it probably have the color of the background, it could even say have the function of the house. Maybe it opens automatically, maybe it opens Wi-Fi, that kind of thing. So the blueprint, you're going to see some similarities with with objects, right? It describes itself using things that it has, and it also describes itself using things that it does, right? But it's not an object. Why? Because a blueprint at the end of the day is just paper. It's just plans. You don't actually have an existing house when you hold a blueprint. You get a house when you actually build it. When you get a house when, say, you have a blueprint, right? It's all well and good. You finally build the house. Now that house actually has walls, that walls has color, has this certain size. It exists. It has these properties, and then these properties have values. So one way you can think about it is the class creates the variables, but it doesn't actually give it data. So it all just gives none. So like the color of the house, it can be anything. So just know that it does have a color, but I'm not going to give it a value. But when you make a house, you have to give it a value, right? It has to have some color. So a class is a blueprint for an object. An object makes a class actually exist. It is an actual example. So a class in this case would be like a common noun. It's the general term. It's the idea. But the object would be the material thing, the one that exists, the implementation of the idea. It's something that you actually have values for the properties, and it actually has the functions, and it can actually change things and interact with other things. So that's the intuition with objects and classes, using employees, cats, and houses. Now, with that out of the way, that we have some intuition with objects and classes, we can probably move on to actually creating our classes or implementing our classes and then creating our objects ourselves, which is kind of exciting. So I'll start sharing my screen now. Employee. Oh, okay. So we've been discussing about the employee class for a while, and let's actually implement it right now so that you can have an idea. Because I've been discussing about abstracts to you, but now we're going to actually make the class. So to create a class in Python, you will first type in class as the keyword. So it's similar to function really, except for function, it's def. But here it's class, and then the name of the class. So let's name it employee. And then similar to function, you probably just go colon, enter. And then from here on, we have to indent everything just so that the program knows that everything we put here is inside class. Okay, great. Next, we want to define the attributes of this class. How do we do this? Well, there's a special way to define attributes in uh, there's a special way to define attributes in classes, and you usually do it using the init function. So bear with me, this is a little complicated. So let's first create a function called init. So that define, and then you use double underscores, underscore, underscore, init, underscore, sorry, underscore, underscore, and then it's a function. So we have an open close parenthesis here. Okay. Uh, I'll close this for now. So what's this init function? What's with the double underscores? Well, for classes, for methods, sorry, for methods in Python classes, there are actually special built-in methods that they reserve using double underscores. And what it does is if you define those methods, you create your definitions of it, uh, you give certain special properties for those classes. There are a lot of methods like this. We usually call these methods dunders or magic methods. But for our case, we're really just interested with the dunder that creates attributes that allows us to initialize the attributes. So let's break this down. So you know that this is just a function, right? Just a function or a method in this case. So it's just a method. The first argument to the init is self. Why do we do this? Well, we pass self because we want the object to know itself. Sorry. Uh, Bad joke. But the we want the but it is true. We want the object to know the properties and the methods it has, the attributes that it has. And the only way it can access its own attributes is if it knows itself. And you're gonna see why, because let's just define self. So self's already there. And let's finally make the attributes that we want to make. So say we want to make employee ID. The way we do this is self dot and then the name of the variable. So employee ID. And then let's give it none for now. Okay. So this is how you create an attribute in Python, Python classes. So you give the self first, at least inside the class. You give the self first. So you're saying, okay, I, the object, I'm referring to myself. I want a variable called employee ID. And then I'm going to assign the value of none to that variable. That's why I want to make this connection that they're really just collections of variables and functions because they really are, but we want to think of them in a different way so that it feels more intuitive to you. But yeah, in this case, it's really just a variable. You just have self dot. Okay. Next, let's try department, none, and then self that company is equal to none. Okay, we don't want this actually because we want them to actually have values, not none. So how do we do this? Think about it. You have a function. How do you get values for your function? You get them as arguments. So after self, once you know what object we're talking about, we can probably give more than one arguments. You can not give any more arguments if this is fine for you, or if you want to actually give them values, you can take multiple arguments. So for our case, let's do arg1, arg2, arg3, and then give them that value. So now when we uh the inputs that we get here, we actually set it to the specific variables. Of course, for convention, we don't actually want this. This doesn't seem readable. It's best to have them use the same name. So for employee ID, it's probably best to do this. For department, do this. And then for company, we do this. Sorry for that. Okay. So we have finally created the attributes. Let's do one more thing. Let's create a method. And let's just do work to illustrate why we actually need the self. So every function in the every method in the class uh, would usually require self, so that again you can access your own attributes and methods. So let's define the function, and let's say I want to print that I am working at the department. What department? Well, what's the variable that contains the department? It's this. It's department. It's this. But the only way you can get it is you first need to know that it is your department. So it's self dot department. So that's the reason why we need self. So that we can access these attributes that we've been setting earlier using init. And then we actually finish implementing the class employee. That's all well and good. But as I've said, that's just a blueprint. You don't actually have an existing thing. So let's actually create our own employees. So employee one. The only way to create an employee is to first, of course, have a variable name, equal sign, and then to create a class, you would give it its name. So the name of this class is employee, and then open close parenthesis. You can see here in the tooltip that it accepts employee ID, department, and company, but it doesn't accept self. Why is that? Well, it doesn't accept self because it automatically sets employee one as self. So you don't have to worry about it. You can ignore it completely. Just worry about employee ID, department, and company. So let's say for my case, I want employee ID 123, department HR, and then company uh, X company, and then we have an employee. What do I to prove that it's actually an employee that works? Let's try to do let's try printing the values of an employee. Okay, so pop quiz. How do you get the attributes now? Because inside the class, you only needed to use self. But in this case, you don't have the self. Well, I've already given a hint actually here because uh, self in this case is the object. But we already have access to the object. So you just go through the object, dot, and then give it the property or attribute that you want to print. So in this case, let's print employee ID. And then let's print department, and then let's print company. Let's run this code. So I'll exit the console. clear. Let's go for Python employee. Oops, employee. I'm sorry. You need to do cd demos first. And then Python employee. Did we save? Ah, we haven't saved yet. Okay. Oh, so you can see here that the 123, the HR, and the X company has been saved. That's great. So you've made essentially here in this case a class that has attributes employee ID, department, and company. And that also has the method work, wherein it can have access to its own attributes and you can do some stuff with it. You can interact based on what you know and based on arguments. You can take arguments with here as well. It's a default function. Just know that self, as always, is going to be ignored or it's automatically handled for you. You don't have to worry about self. Just know that you need to use it when you want to access the attributes. And one more thing before we end this discussion. Let's say we create a new employee, employee 2, and even though it's the same thing, let's try to do this. Employee 1. Let's run this code. They have the same variables, they have the same attributes, they even have the same functions. But when you try to equate them, they're actually false. Why is that? Well, even though they have the same attributes, and then you also have the same methods in this case, uh, we're talking about employee here, which is saved in memory. So when you create an employee class, you create something new. So it's similar to how so you create something new, right? But this thing is still exists in memory. You can't you didn't if you try to do employee 1 is equal to employee 2, so similar to this, it would equal to true because they're the same thing. The variables they have an alias that points to the same value. But for this case, you just created a new employee. So inside among all things, it's a different thing. It's a different object. Uh, so even though we try to make this point that, oh, they have the same value, they have the same methods, so they're kind of like the same object, I did mention earlier that even though you have the blueprint and you create those houses, there's still two different houses, right? You build the same house, they have the same color, there's still two different houses. So that's the intuition I want to handle, to give to you before I end this lecture. So I'll stop sharing for now. So in this video lecture, we were able to discuss uh, functions and variables, and then in that context, what objects and classes are, and then we've implemented our own classes in Python. There are a lot of things that you can also learn here. There are other Dunder methods. There are better ways to implement classes for something like this. There's even an advanced concept called data classes. There are a lot of things that you can also go deep into, but for the sake of this video, this is the summary and this is the basics of object-oriented programming in Python. So thank you very much. Hope you have a great day still.